So let's start our discussions on Java, but by trying to see exactly what is the problem that Java was trying to solve. At the time Java emerged, there was C, C++, Visual Basic, and Python. Okay. C, C++ was and is still pretty big on the market. Visual Basic now has become part of the .NET framework, but that was more of an event-driven programming in which it was very easy to code in Visual Basic. Python has remained more for academic, and it hasn't really caught on very, in a big way in industry as such, but still it's been more popular in academic circles. Java was basically to come up, I won't say to replace C++. It came up as an alternative to C++, and it came up with, a different outlook from C++. So you'll find many language constructs and all that the same, but you'll find that there's a certain outlook, that Java has that C++ differs. So one is C++ does not provide efficient garbage collection. So this is all part of the memory management. Okay. So the first point and the last point, memory allocation, deallocation in C++ was done by the developer. Primarily, this used to create a lot of problems in programs. So, okay, in a ideal world where every developer is good and everyone, doesn't make mistakes, that it's fine. But the reality is bugs and mistakes continuously keep happening. And C++, the way it handled memory could cause programs to crash, and sometimes not just the program that you have written, but maybe some other program. So Java actually took a different and more safer approach to ensure that programs did not impact the memory used by other programs. So Java memory management is quite different. We'll be coming to that. C did not have a built-in support for threads. So basically what threads are, Java provides a capability of running from your code, running 2 or more programs simultaneously. So initially C++ did not have this, but that capability is there with Java at that time. And C++ did not have a very rich graphic interface libraries, and Java provides that. And then C++ is not platform independent. So Java actually wanted to be platform independent, means once you have compiled the code, you should be able to run it either on Windows or Unix or Linux or any other operating system. So basically Java is platform independent. That means it does not depend on the underlying operating system. Java was basically something developed by Sun Microsystems, and James Gosling, he headed the project. It's platform independent, which means it runs on any platform. So as you can see, we've had regular releases of Java. It's from 1996, 97, 98, and then 2000, and later on started with every year a new release, then every 2 years, and now the releases become every 3 or 4 years. But even in 6, you'll have 6.1, 6.2, you'll have many releases over there. The latest release is 8, and it's still in beta phase, but it appears to be quite stable. So it's important to know that when Java creates a new release, it's part of the Java community process where the Java community basically makes suggestions, they are prioritized, and then they are evaluated, and then they see which are the suggestions that are worth implementing, and then they are prioritized and they are put into the next release. So what are the main features of Java? It's simple, secure, robust, portable, dynamic, multi-threaded, object-oriented, and high performance. Okay, the graphic talks about platform independence. So yes, earlier, everything was very proprietary, and people tended to have languages that just ran in one OS. Java from the very start is a community-driven open source language, and the intention was it could be used on any operating system. I'll come to each of the features separately in different slides. Okay, the first feature, platform dependent. So, okay, if you look at C++, I think those of you who have used other languages or who have studied, any sort of IT or computer science in college will be aware that when you write a code, you use a compiler, and the compiler will create an executable file, or if it's, or a shell script or whatever. Okay. So these files basically, after compilation, it creates a file that is understood by the underlying operating system. And because the output of it is a file that's understood by the underlying operating system, it means that every time you have a different operating system, you need to compile it. Okay. And very often, many of the features also, language features may be operating system dependent, which makes it difficult for those languages to run on more than one operating system. So you have source code, it compiles, and it gives you an executable file depending on the operating system, but basically that's a file that is understood directly by the operating system code. Java is slightly different. So you notice the key difference with Java is that you have a JVM, which is called a Java virtual machine. Now each operating system has the JVM installed on it. So you have the Java virtual machine installed on the operating system. And then what happens? The Java code that you write, when it is compiled, it creates Byte code, which is a .class file, and this .class file is understood by the JVM. The Byte code class need not be understood directly is not a class that can be directly understood by the operating system. It's the JVM that runs the Byte code class. Notice the previous file, that each of them after the compiler runs directly on the operating system, and in Java the JVM stands between the operating system and the compiled class, and that's how it's implemented independent of the operating system. Okay, so we said Java is simple. So what do you mean when a language is simple? Just ignore what's on the screen. So let's take a look at some very simple features, things that make Java simple. First is in C++, you allocate memory, you have pointers, you move the pointers, all that. Java, the memory management is done totally by the operating system. All you need to do is you declare a variable. Java automatically allots the memory available for the variable and it manages it. If an object is instantiated, Java automatically will allocate memory for the object. You do not have to do it. So the memory management aspect that was there in C has been removed. Okay. What else is there? Java, basically, in order to make the language simple, it supports single inheritance. It does not support multiple inheritance. And it doesn't really lose much power by not supporting multiple inheritance. So this is another feature that makes sure that your code is very simple. Java also, when you look at the various Java frameworks, they have something called code by convention. I'll give you an example of this. Let's just say I have a table in the database called employee. Now, if I create a class employee, and of course I put the annotations that are necessary needed by Hibernate, Java will automatically understand that that employee class is linked to the employee table, refers to the employee table. I don't need to write any code to associate a class with the table. Now let's just say in the table I had a column ID, employee name, employee surname, date of birth. If in my class I have instance variables with these same names, Java will automatically associate them with the same names in the table. So when we are looking at Hibernate, this will be shown to you. But code by convention is something that makes your life very easy. You don't really need to write complicated code to link a variable in a Java class to a field or to a table in a database. Similarly, when you have forms, by following a certain naming convention, you will find that Java will automatically link them to the correct beans, to the correct variables and beans. So we'll find this something else, code by convention, that really saves you a lot of coding, and it cuts down on bugs, and it makes things very simple in Java. So Java has a very good security API. The language itself, because of the way it manages memory and other things, don't allow other applications to interfere with your application. It basically provides security at two levels. One, it has its own security API, and when it comes to web applications, it has a lot of security, particularly with beans and all that. Okay, so you'll find it has a lot of security features. So it's robust. So when we talk of robust, like we want an application not to fail. Okay, and it should be able to recover from errors. So Java is probably scores a lot of brownie points in that area. So okay, it checks code during compilation time. You'll find that the IDs also will give you a lot of information. If they find that certain code is not reached, you'll find warnings in the ID. At some stage, when I'm taking you through the ID, you will see the basic, you'll see these type of warnings, which I'll point out to you. Because of its memory allocation, and it's not leaving this, that was a source of a lot of bugs. And so Java's way of handling memory, instead of giving it to the coder to taking that responsibility, reduces a lot of application errors, making the application more robust. Portable. So when we say portable, it means it can be used across many platforms. And this has two aspects. One is, can you use the code across many platforms? And the other is, can your code be written in such a way that if I want to use it on a web, I can, the portion that I use on a PC and the portion that I use on a mobile, like there's a certain part which I don't need to change, and just I need to change the UI for both, right? So Java has a lot of frameworks that help you to do just that. So it's dynamic. So we'll look at some of these features out here. So we say there are many objects that are evaluated at runtime and execution is carried out. So one of the examples is runtime polymorphism. We'll also see basically certain patterns that are there towards the later part of the course, and these patterns help you to write a lot of code that's dynamic out here. So basically dynamic would mean that you don't declare some object at the very beginning and you're stuck with that, but you can select exactly which object you want. For example, if I'm using writing a payroll program, I don't have to have a certain type of employee right through. So I could have employees, and they may be permanent employees or contract employees, and basically as we encounter it by inspecting certain properties, we can in that employee class we can decide which type of employee it is. So you'll find various types of dynamism out there. It's distributed. So I did give you the example of Hadoop, which is very extreme, where you have huge data sets lying across multiple computers and computing across multiple computers. More traditionally, when we talk of distributed applications, we are talking of maybe of the same company. So I may have a bank may have branches, and each branch can have its own server, and these servers can be integrated at some other stage. Or more, a company, in fact I worked for a pharmaceutical and distribution company, and they had manufacturing systems in Australia and Thailand, and they had a distribution business in maybe about 18-20 companies. So they would have servers in many places, like even they had in a place like Vietnam, and they had servers in Ho Chi Minh and Hanoi and 2-3 other places which are quite remote, and you cannot access them through VPNs, through lease lines and all that, because connectivity is not very good in those countries. But we could still have databases that in various cities, and we could actually combine them online at periodic intervals. Distributed can also mean when you want to make it more highly available, you use a cluster, so that depending on which server is available, you will send the request to that server. So I worked with a metro rail system, and that was real time. The responses had to come immediately because they are from various devices that communicate. So any signal received from a device cannot be missed, and these things had to be done. So we found Java very good in handling. So we would have a load balancer, and that would decide which server to send it to. So that's another strength of Java: distributed systems, distributed computing. Multi-threaded. So a thread is a task in a process or program. Multi-threading is multiple tasks running and executing at the same time. This facility is provided by Java so that many tasks can be executed at the same time. So if you look at your operating system anytime, okay, so you'll see there are many processes out here, right? So we say it's a multi-processing system. So you have Acrobat Reader running, you have Chrome running, I have Notepad running, I have many processes that are running, and all of these processes run at the same time. So similarly, Java can have multiple threads, and each of the thread is, in the context of Java, a process. And each process runs in its own thread. So one quick question. So why do we use multi-threading? So many people would say we use it to improve performance, because if I'm doing 2 tasks at the same time, it's going to be faster. I'm going to ask a question. I'll answer this in the class on threads. That, okay, let's just say I have a computer and it has one CPU, right? One CPU means I can execute one instruction at a time. I think if you worked on any type of programming language, you'll be aware, right? So the CPU can only process one instruction at a time. If your computer has 2, 3, then okay, maybe it can do 2 or 3 at a time. So why would threading be needed? Okay, so this is a challenge question. Just keep it in mind. I'll answer it in the multi-threading class, in the class on threads rather. But just see if you can figure out the answer in the meantime. But basically, threading is there to improve performance. How? That's my question. Okay. So it's object oriented. The importance of being object oriented. Okay, object oriented means everything is performed using objects, and objects are things that mimic real life. That's good. What is the importance of being object oriented as compared to being procedural or the previous paradigms, right? Well, in today's world, when a program is written, the main thing, the number one concern would be that someone else can change the program. So, in fact, earlier performance was the only thing we worried about. Today, performance may rank well below maintainability of code. Even in a project which has very, very strict performance parameters, still you would want your code to be maintainable. And of course, there is a good reason for that. Because if code is not maintainable, then all sorts, whenever you make changes, it becomes bulky and cumbersome, and you tend to copy the code just to make sure that the changes don't impact anything that's existing. And at the end of it, you get a very bloated code. So object-oriented is very important. And I can't stress this point enough. I'll say, today when we talk of an enterprise, the basic definition of an enterprise is something that's going to change. If there's one property that you have in an enterprise, it's that it's going to change. When we talk of management today, or when we talk of leading applications today, we want disruptive managements. People want to say, my application is disruptive. Earlier, when a person spoke of his application, he'll want to say, my application is very efficient. It will make you do this faster. You can process your orders in a few seconds. You can allocate your stocks, in minutes. Your sales vans can move out by 9 a.m. Even if the people have come in the evening, the invoices will be processed, and your sales van, I assure you, by 9 a.m. or maybe 8 a.m. in the morning, they can move out. Today, applications want to be disruptive. What they want to do? They want to say, I've shaken the industry and established myself as a leader. And every organization, if you see any bank, it must respond to anything its competitor does. Any telecom company must respond to anything its competitor does. If you're in the B2C space, if your website is not responding to challenges thrown by its competitors, it will disappear tomorrow. So change is something that is inevitable. We've even heard the term agile. How agile are you? How fast you can change? And when it comes to code, object-oriented code ensures that you can change very, very fast, that you are agile. If there's a disruption, you can respond to it and minimize the impact on your business. So object-oriented code is the most important aspect in all this. And finally, we come to performance. So yes, Java has a lot of performance advantages. We'll see it has many technologies. When I talk of performance, I just don't mean the speed at which code executes. I mean, let's just say two organizations are, communicating with each other. I just want to make sure that I'm sending a message to another organization. I don't need to wait for the response. I don't mind if the response comes later. Is there a mechanism for delivering the message later? And we'll see there are technologies like ESB and all that provide multiple ways of two organizations communicating with each other. You can communicate by uploading a file. You can communicate through messages. You can communicate through web services. You can communicate through HTTP calls. There are multiple ways where you can communicate to each other. The whole idea is that if I want a communication where I want 100% delivery guarantee, there is a means of doing it. If I want a communication where I want an immediate response, then there's a way of doing it. If the response fails and I don't get the response immediately, I can retry. Or, it's like a web page. If the web page doesn't load, you can retry it. But there are certain other communications you want 100% guarantee that it happens, like particularly when you're talking about communications made by machines to machines. Well, there's a way of doing that also in Java. So it gives you many, many different ways of communicating between systems.